Then tomorrow, we're going to look at some different dimensioning techniques, and then pretty much for the rest of it, we'll be focusing on how to dimension specific types of geometry, because we do have some rules we follow for negative cylinders, positive cylinders, angles, these types of things. So that's in essence how we'll cover this chapter. Get the terminology out of the way today and tomorrow, and dimensioning types, and then we will switch to specific types of geometry. Again, what we're looking for here is when we provide the size description of objects, we're looking for consistency. Okay, so when somebody looks at one drawing, they see a negative cylinder dimensioned a certain way, they look at another drawing, it should be done the same way, so that we aid them in deciphering this information. All right, so let's start at the start of the chapter where they go through your terminology. In essence, we'll be mostly on page 822. So you have figure 17.5 that specs out most of the terminology of dimensioning. Now, of course, this is backed up by the text. So I'm not going to hit all of these because we covered some of them yesterday, but let's just kind of zip through them. If you wish for me to stop and spend a little more time on something, please let me know. All right, number one is a dimension. We covered that yesterday, right? Dimension, continuous line, termination arrow, text preferred in the center. Any questions on what a dimension line is? I've got one for you. Do I have to use an arrow like they have here, a closed-filled arrowhead?
No.
No, I don't. Right?
Company
That will be
discretion.
up to the place that you work. Now, what they'll do is they'll have one termination for you, and you will use that. But it does change. What's number 2 on there? Right here, a basic dimension. Okay. Number 2, a basic dimension. So what's different about this one? A standard dimension, but they put a box around it. A basic dimension is considered really a datum or a theoretical perfect dimension. We use it for pulling location or size dimension for other features off of that. So what they're saying right here is, hey, this is going to be your base. Okay? This is where we are going to pull your dimensions from. We need this to be this size as close as possible. And so that's what they'll do, is they'll slow down at that point, and they'll realize that everything is kind of related to that. You rarely have more than one of these on a drawing. You can have up to 3. Well, actually, you can have more than 3, but typically you'll rarely see more than 3. Why would I have 3 of them? Keep in mind, it's a theoretical perfect dimension. Yeah, for our 3 dimensions, right? This would be a height, basic dimension. We could have a width, we could have a depth. And we could have more than that, but that's getting into very specific items. So a basic dimension, a theoretical perfect dimension. Where's 3 on there? Reference dimension. A goodie. Okay. Reference dimension. Again, another dimension, but this one has brackets around it. What is a reference dimension? A dimension not needed for construction. So it's an unnecessary dimension. Now, let me quantify that. Should there ever be an unnecessary dimension? Not really. We call that double dimensioning when we have unnecessary ones. What we're doing here is we're telling them, we're going to give you this dimension. You do not need it to construct the item. But it's a useful dimension to have. Maybe in the assembly process, maybe in the shipping process, something of that nature. Okay? So we're saying, we're going to give you this dimension, but you don't need it to build it. Now, if you look at this guy, why is this a reference dimension? Well, if you look at it, in essence, what we have is a negative cylinder and a positive cylinder here. Notice that it's been the negative cylinder and the positive, both the centers have been located in the height direction. Then, since it comes in tangent, it's also done in the width direction. It has a radius right here. Doesn't the height to the center plus the radius give that dimension? Mm-hmm. It does. Okay, so therefore the 2 is not needed. They have to have this one and this one to construct it. But then we're saying, hey, you know, maybe this got to fit in a box of this size, so we're going to give you this thing, and it's going to be used by quality control or shipping or something of that nature. Okay? So a reference dimension, an unneeded dimension for construction. Good idea to include them. Okay? You can save some people some work. And again, if we have people doing math, we expect them to do math on the job. Just like we are expected to do math on the job, it's not a bad thing. But again, we want to limit it as much as possible so that we reduce mistakes. I think all of us, we've added 2 plus 2, and at some point in our life we've gotten 5. If you went to Kimberly High School, you were taught that's the right answer. But, just kidding. But, you know, we do make those mistakes, don't we? All right, so that's a reference dimension. 4 is a dimension line. We've already covered that one. Any questions on that guy? Okay. 5 is the arrows. We've already covered that one. 1/8 inch. Width is always length divided by 1/3, closed filled arrow. 6, the extension line. We've already covered that with its dimensions. Remember, thin line, 16th gap off the object, 1/8 inch past the arrowhead, ties the dimension to the feature. 7, the visible gap, that's just for the extension line. 8, the leader line, we covered that one also yesterday. Arrow terminates on the outside object line, typically 45 degrees. You can go 30 to 60. Has an 1/8 inch shoulder. Text is centered on the shoulder, or the landing, whatever you wish to call it. Any questions on that one? Okay. 9. Actually, 9 and 10 are very similar. 9 is limits of size, 10 is plus and minus dimensioning. These are tolerancing techniques. Remember, tolerance is the amount of slop we'll allow them when they build the object. We can include that right in the dimension. So if we're using a limits of size, like up here on 9, this is a tolerancing technique. We're telling them that the width of this object right here can be a minimum of 2.490. It can be a maximum of 2.510. Now, if you are constructing this item, what would you try to build it at? You'd shoot for right in the middle, right? Because you know you can't build it to exact size. So you're going to shoot for the middle so that you have the maximum amount of error that you can do when you build it. So that's a limited size. This is a tolerancing technique. I would expect this thing to be built right around 2.5, giving this dimension stop. This is the same thing, plus and minus dimensions, but it's listed different. It's given a basic size here, and then a deviation in the positive and negative direction. Now this can be kind of weird. You want to pay attention to these on the plus minus, because what we're telling them here, I think that says 1.25. Does it? Okay. So we're telling them that's the size we want it. We want it 1.25 inches, or yeah, it's 1.25 inches. Okay. We want it that size. But we know you can't build it to that size, so we're going to allow you this fluctuation. You got to get to where I can see this thing. As you look at it, now notice that in this one, there is actually a lot more deviation allowed in the positive direction than the negative direction. So in essence, if I'm constructing this, I'm saying, hey, you know what? I'm going to try for 1.25 inches, but I'm going to make the thing a little big if I have an option. So I'm probably shooting for 1.3, somewhere in that, or 1.26, 1.27, right in that range. And that would keep me in that tolerancing zone. What happens if a part's built and it's outside of that zone?
Something might not fit.
Yeah, the part's rejected. Okay, we're not going. It's going to go through a quality control process where somebody's going to check this stuff. And if it comes outside of that zone, that part, if it's too big, we can probably send it back to the person building it and say, hey, you know, you got a little fudge room, I need this a little smaller. If it's too small, you can't really make it bigger. And so we're probably throwing it away.
Isn't that opposite? If it's too big, you can't make it smaller. If it's too small, you make it bigger.
Well, we can't make it bigger unless we add material to it.
Well, if it's a bowl, we can bore it.
That's just the center. It's just the center.
Oh, okay.
Okay. So we need those to be in. So the point being, if we don't fall in these ranges, here tolerancing, here tolerancing, the part's rejected, right, for some form or fashion. Can we then salvage it? Yeah, maybe, maybe not. Okay. Does that kind of make sense? Maybe I said that incorrectly.
Is the minus .01, did they give less? I mean, is it typical to give less deviation than the minus to?
It all depends on the functionality of what we need that part to do. Okay, you can see a lot of different things. The thing you got to remember here, if I take that dimension, so I got 1.250, and I can go, it's minus 0.10, right?
Yep.
So my allowable sizes here are from 1.15? Not being able to see that. It's 0.01, isn't it?
Or 0.1.
Yeah, 0.01.
To be 0.124.
Okay, so 0.24, that's the smallest it could be. And then the largest would be 1.25 plus 0.032. Okay, so this would be 1.282. Is that correct? Okay. So that's their range. This would be the same as doing a limit dimension, but here we're telling them we prefer it this size. Okay. So just slight difference in how we're doing that tolerancing as it goes on. Keep in mind that we have general notes. I asked you to put a general note on that said all dimensions plus or minus 0.02 inches, and this should sit down in the bottom right hand. Okay. Now when I say that, that applies to every single dimension out here. So it applies to that one, that one, that one, that one, okay, that one, all of them, except for this one, because we took the time to do something different here, and that one. Okay, here we're removing that general tolerance off of those. And we're applying a direct tolerance. But general means applies to drawing as a whole, direct to the one dimension. So the point, we'll get into, we're not going to do any tolerancing probably for about 3-4 days till we get through the basics, and then we'll go into the tolerancing portion of it. But here's a couple examples of the ways we tolerance. 11. Any other questions on these four, Lima? 11 is the diameter symbol. Should precede the number. You only use diameter when you have a full circle, positive or negative. Okay. Positive or negative, full circles. This is different than the text. The text states that you use diameter on 180 degrees and larger. That's not correct. What we do is a full circle gets diameter. Any portion of a circle gets radius, the next one. Okay, this one right here. So portion of a circle gets radius. Doesn't matter if it's 359 degrees and we got one little 1 degree arc out. You use radius. If it's all the way, full circle, use diameter. Any questions on those two? Keep in mind that diameter and radius should precede the dimensional information. I think that's about it, isn't it? Let me make sure I hit everything on my notes. Okay, I think that's it. Any questions on those definitions? All right, when you dimension, I think you should look, you always are looking for these three items, and I'll just kind of throw my notes up on these real quick. We have three things that we do when we dimension. We have what we call geometric dimensioning or contour dimensioning. This is placing the dimension in the best geometric look of the object. We'll talk about that more in a minute. That's the very first thing you do when you dimension. So you look at a feature and say, hey, I've got a really good profile look of this feature. That's where the dimension should go. That's contour dimension, or yeah, geometric. Your text uses the words kind of synonymously. You also do associative dimensioning. Associative dimensioning is placing dimensions between multi-views so that you can use the dimension on two different views. The last thing you do is what's called grouping. Grouping has really two meanings. It is placing like dimensions together. So we want to try and keep as many dimensions in the same place as possible so somebody's not hunting for them. We do that on the object as a whole. Then we go back and we look at individual features because many features need location, need size, maybe a couple sizes. When that's the case, we might have to group by feature also. So I don't want to take some object, put one dimension on it, and then take the location dimension and stick it on some obscure view a long ways away. How do we do those three? Let me just give you a quick example. Let's go to, I think it's 836. And let's look at an object the author dimensions for you. So we're looking at figures 1740 and 1741. Okay, so we'll stick with 1740 for a second because this has contour dimensioning. So here's the wrong way of doing stuff down here. Here's the right way to do things up here. Same multi-views. Now if you look at it, here's how we break out the contour dimensioning. So across the bottom here, they've dimensioned this slot that we've got this little, it's right here, it's a square slot. They put it down here. Now notice as you come through here and you see those dimensions that are pulled out here, do we know what this shape really is from this view? We don't really. This thing could be an indent here, could be an indent here, could be an indent here, it could be square, it could be circular, it could be triangular. We really don't know what the shape is. If you come to this view, do we now know what the shape is? Because now we're seeing the geometric or contour of those lines. That's why they're saying these dimensions should go in here. Because that's where we get the good look at that feature. We get it here, not down here. Same with this guy. In the top view, we know that there's a hole because it's got a center line. But again, we don't really know much else about it in this top view. All of these dimensions should be placed here because here's where we see what the shape is. The height here, great example. You'll see this a lot where people have dimensioned that height right there. Well, we've got an interior to the object. This is a much better look at the height of what that bottom plate is. So therefore the dimension should be sitting right here. You kind of get an idea of that? So contour dimensioning, putting the dimension in your best look at the feature. This should be the first thing you do with everything, and it kind of overrides all of them. Right? That's contour dimensioning. Now, once you go through an object and you do your contour dimensioning, then do associative dimensioning with it. Can I move them in between so that I can use them in two different views? Like this one. So I've dimensioned down here. Well, here it's not in between here. For me to make the connection from here to here, I have to go through all this geometry to get there. What we're saying is, let's stick those dimensions in between the views like we've done here, and then it makes very apparent, because we know multi-view, we're just going straight in between all those views, right? We're projecting straight. So I can use these dimensions here with this view or this view. I can use this one with this view and this view. I can use these with these two, this one with these two. I'm sticking it in between. so that I can use the dimensions with multiple views without sitting there and pulling a scale or a triangle and trying to interpolate across a big sheet. Keep in mind, this might be a D sheet. Most of us don't pack around scales that are 24 or 36 inches long. So we want that stuff in between. So first contour, second associative. Okay? Put the stuff in between, if possible. If you can't, leave it out. There are cases where you're going to leave it on the outside, but they're pretty rare. Last thing is grouping. Group dimensions of like dimensions, I guess might be a better way to say it. Just group your like dimensions. And I don't know that this one gives us, well, it does. Let's look at this little slot right here. See how they have all the dimensions for the slot right here together? That's how it should happen. It should happen where everything's right here. I shouldn't come and take the height and stick it over here where I would have the size. I've got this location, but I don't have this one. I move it off somewhere else. Well, let's put all three dimensions that I need for that slot in the same spot or with the same view. So as they start to construct that slot, they're just looking at one thing. Saying, okay, I need that, that, I can build it. Okay, and they're not hunting for these. Okay, grouping. This one over here really has probably the better example on these two negative cylinders. Here they've located it across the top, they've located it on the left side, and they've sized it right here with it. Okay. Good job of grouping on that. There's association, they put it in between. It's also contouring. We see the best look at it right here. So in essence, this is what we're asking you to do when you dimension an object. First, where do you see the best geometric look? That's where your dimension should go. And you'll go through and look at every single feature and do all of them that way. Once you do that, then you go fine tune it. You say, okay, now I need to do associative dimensioning. Can I make sure those dimensions are in between my multi-views so that they can use for both? Then lastly, I look at all the features. Do I have all of the things necessary for this feature to be constructed in one area? And so I group them. Now, those are just guidelines. Keep that in mind. They're things we do. They aid us. They're not all-encompassing for every object. But they're guidelines to get you there. Contour dimensioning, associative dimensioning, grouping. Three things you want to follow with every object you dimension. Any questions? All right, I just need to cover one piece of geometry you're going to need for your assignments if you get there. Dimensioning angles. We're going to look at this in two places. Let's go to the start of the chapter on figure 1710. So how do you do angles? Our old nemesis, maybe not anymore. What kind of plane do we have here?
Incline.
Inclined planes. They create angles, right? When you do angles, you can dimension them two ways. You can do them with a length of the triangle and the angle. That is ANSI approved. You can do that, but it's not the preferred way. The preferred way is to give both linear dimensions for the angle. So by that, I wouldn't use this one. I would use this one. Okay? So we would prefer to have linear measurements versus angled measurements. So can I still construct this given this distance here and this distance here? Yeah, I'm given two lengths of the triangle. It's, in essence, we can make a right triangle out of that. Why do we like linear measurements more than angled measurements?
More accurate?
Much more accurate. That's exactly why. More accurate to measure, more accurate to construct. Okay. Angles are tough to hit consistently. And if you have machines that work on angles, you're calibrating them all the time because they get off. So we want the linear stuff if possible. Let's look at another diagram where the author really kind of points this out. Did I write this? Figure 1743 I've got written down. I don't remember that being right. Yeah, it is. Okay, here's 1743, where the author compares and contrasts the two methods. So they're walking you through how to dimension an object. Here is the preferred method of doing an angle. So again, we have that surface. We want that leg. We want that leg. That gives us that point, we can make the cut. If you can't get that to happen, you can do it this way, where I give one leg of the triangle and the angle. Now, when we're producing these dimension lines for an angle, use your circle template based on the center of the circle. Okay, so you're going to set your circle template up. Okay, remember, we want this approximately a ½ inch off. So your diameter of 1 inch is a good circle to use. Set your circle template up where there's the center of it. And then you can use the edge of the circle template to draw that arc, and then add your arrows. Does that make sense? I don't have my circle template up here where I was. Is there any questions on what I'm talking about there? Boy, that went pretty fast. I need to speed slower. Any questions on what we talked about so far? Okay, I did hand out an assignment sheet. We do need to do an adjustment on how we draw, so I want to look at those. If you would look at the first one, you got IDM 1A and B. These are two separate drawings. Let's go to the page where they're at. So 866.